Hi, good morning. This is Dr. Venkateswarlu, NB. I love to introduce my recent book, Joy of Computing. Rather, I love to introduce or explain a puzzle discussed in this book, that is, an evil king and his wine bottles. How he identifies a poisonous bottle among the given n bottles. This will be explained with respect to the binary system. The problem can be explained as follows. The king is having n bottles. The spies conveyed that one of the bottle is poisonous. The important aspect in this puzzle is how to identify the poisonous bottle. Just for the sake of explanation, assume that we have 8 bottles of wine. The numbers are 0 to 7. Their binary codes are also given on the bottles. Assume that the king selects the bottles 1, 3, 5, 7. That is, if you observe the binary codes of these numbers, their least significant bit value is 1. Those bottles are selected. From each of them, one drop of wine is taken. The drops that are taken from the bottles, wine bottles 1, 3, 5, 7, are dropped into glass number 1, which is given to the taster 1 to drink. Now the king selects bottles 2, 3, 6, 7. That is, their binary codes, if you observe, their middle bit is set, that is 1. These bottles are selected and from each of them one drop of wine is taken. All those drops are kept in the glass number 2. This is offered to the taster 2. Now the bottles whose numbers are 4, 5, 6, 7, that is, if you observe, their most significant bit value is 1. All these bottles are selected. From each of them, one drop of wine is taken. The drops of wines that are taken from the bottles 4, 5, 6, 7 are kept in glass number 3, and then the same will be asked to be taken by the taster 3. In total, glass 1 contains the drops of the bottles 1, 3, 5, 7, whereas glass 2 contains the drops, wine drops, that are taken from the bottles 2, 3, 6, 7, whereas glass 3 contains the wine drops taken from the bottles 4, 5, 6, 7. If fifth bottle, whose binary code is 101, is poisonous, then taster 1 and taster 3 will die. Remember, glass 1 contains the drops of bottles 1, 3, 5, 7, whereas glass 3 contains the drops of 4, 5, 6, 7. If you observe, 5 is common, also 7 is common. If taster 1 and taster 3 died, taster 2 did not die. That indicates 7 is available in all the glasses, means the wine taken from all the 3 glasses, they contain the drops of bottle 7. If bottle 7 would have been poisonous, then taster 2 also would have died. That That is, if we know that tester 1 and tester 3 is dead, simply we take 1 at place 1 and 1 at place 3, and in between 0, as tester 2 did not die, the number becomes 101, that is nothing but 5. That indicates that the bottle number 5 is the one having poisonous drink. In the same sense, if second and third testers dies, we take 1 at their locations, the number becomes 110, which is 6. That indicates the sixth bottle is poisonous. Wow, there is another possibility. If none of the testers dies, then which is the bottle having poison? That is nothing but bottle number 0. If you observe, 0 is not seen in the groups of glass 1, that is 1, 3, 5, 7, glass 2, 2, 3, 6, 7, glass 3, 4, 5, 6, 7. So we have not taken any drop from bottle number 0. If it is given that one of the bottle is guaranteedly having poison, that is the problem statement. So thus we can say bottle 0 is the one which is having poisonous liquid. Also, there will be another situation, that is, if all the 3 testers dies, which is common in all the 3 sets, that is 1, 3, 5, 7, 2, 3, 6, 7, 4, 5, 6, 7, 7 is common, which means that definitely the bottle number 7 is the one having poisonous liquid. Like this, with the help of the binary codes, we can identify poisonous liquid, rather the number of the bottle where or in which poison liquid is available. Can you guess what are other cases in which 2 out of the 3 testers will die? There is one more case, that is 0, 1, 1 case. That is, tester 1 and tester 2 dies. Previously, we have explained about the cases 101, 110, 101 fifth bottle, 110 sixth bottle. Now in this case 011 case, 2 people will die, 2 testers will die. Then the bottle which is having poison is third bottle. Can you summarize about the possibilities in which only one tester dies out of the 3 testers? The answer is as follows. The case 001, that is tester 1 dies. The bottle 1 is the poisonous one. 010, tester 2 dies. Bottle 2 is the poisonous one. 100 case situation, tester 3 dies. Bottle 4 is poisonous. Like this, we have 3 possibilities in this example. Assume this time we have 16 wine bottles. The king made an experiment with 4 testers. Second tester survived, remaining all 3 are dead. Which is the poisonous bottle? Can you guess it? The answer is 13th bottle. Assume that there are 16 wine bottles. What are all possibilities in which only one tester dies out of the 4? The answer is given in the slide. These are the 4 possibilities in which only one tester will die. Remaining all 3 will survive. Assume that we have 16 bottles. Then what are the possibilities in which 2 testers will die out of 4 testers? How many possibilities are there? If you observe the table, you find there are 6 possibilities. Assuming that we have 16 wine bottles now, what are the possibilities in which 3 out of the 4 testers will die? The slide contains the details. You may find 4 possibilities. Well, we have discussed the examples where the number of bottles are 8, also number of bottles are 16, etc. In the case of number of bottles 8, we require 3 testers. In the case of number of bottles 16, we require to use 4 testers, which is nothing but if we have n bottles, wine bottles, with one being poisonous, we require how many number of testers? That is nothing but log 2n. Assume that we have n bottles of wine, then we require log 2n number of testers. Out of them, we want to find out what are the possibilities or how many possibilities are there for k testers getting died. So that can be given as number of combinations. If p is the number of testers, you wanted to find out what is the probability, rather number of possibilities of k testers dying. That can be given as PCK. Is this problem can be solved in the similar lines of the puzzle counterfeit coin example discussed in the book? Yes, it is. That is, here also we can divide all the bottles first into 2 halves. Then one tester will be taken, asked to drink the liquid from one half of the bottles, 1 drop from each bottle of the one half, and if he survives, which means that the poisonous bottle is not there in that half, probably the poisonous bottle might be in the remaining half. Now to find out the poisonous bottle, so that remaining half we divide into 2 halves, then the tester will be asked to drink. Like this we proceed, we can find out the poisonous bottle. This also requires log 2n number of testers only. Is this problem can be solved in the following manner? If so, how many testers do we need? The approach is as follows. We take n by 2 testers. Assume the tester numbers are 1 to n by 2. First tester number 1, he will be taking the wine from the bottles 1 and 2. Tester 2 will be taking the wine from 3 and 4. Tester 3 will be taking the wine from 5 and 6. Like this, they are asked to drink the wine. Obviously, the one who took wine from the poisonous bottle, he will be dying. Only one will be dying out of n by 2. Okay, then we require to take 2 testers from the survived list. Then we know that if the kth bottle is kth one is dead, then definitely the bottle numbers 2 into k minus 1 or 2 into k. Those two bottles are the ones probably which are having the poison. So now we take two testers, ask them to drink wine from those two bottles. We can find out now who is the, which bottle is the poisonous one. Well, this is the procedure. How many testers we are using in total? N by 2 only. However, is this is better or the method used by the king is better? That is better. He is using at most log 2 n testers only. For large values of n by 2 is much larger than log 2n. That way his approach is better. Whereas this procedure is a two-step process. This is also one approach. Here the drawback is the number of testers we require will be more. Thank you for viewing this video. The book links are given in this slide and also given below. I welcome you people to have a look at my book and share your views. Thank you. Thank you.